Hello class, in this video I'm going to show you how to use a TI84 calculator to test a claim regarding the population proportion. Let's take a look at this problem. A genetic experiment involving peas yield one sample of offspring consisting of 440 green peas and 135 yellow peas. This sentence gives us the sample size. Sample size is 440 plus 135. Use a 0.05 significance level. So alpha equals 0.05. The researchers think 5% can be the criteria for a rare event. To test the claim that under the same circumstances, 25% of offspring peas will be yellow. We also can see X here representing the number of successes is 135. In this problem, we see getting yellow is a success. So X here representing the number of successes is 135. The original claim is the proportion. It says under the same circumstances, 25% of the offspring peas will be yellow. So the original claim is the proportion, population proportion is 25%. That's the original claim about the population proportion. Identify the null hypothesis, alternative hypothesis, test statistic, p-value, conclusion about the null hypothesis, and the final conclusion that addresses the original claim. Use the p-value method and the normal distribution as an approximation to the binomial distribution. So it specifies use the p-value method. And then we are going to use p-value method. So let me remember the number of successes 135. Significance level is 5%. Original claims p equals 25%. So the null will be the same with the original claim because null has to be an expression including an equal sign. And alternative would be p is not equal to 25%. This is a two-tailed test, all right? Two-tailed test. Instead of using critical value and find the area of the region and double the region, double the area, very complicated. We are going to use the TI84 calculator. I'm going to stop share this note and share the TI84 calculator. Give me 1 second. Let's wait for the app loading. Okay, right here. Right, so we go to stats. We go to stats and the tests, and then we are going to this is a one proportion z test. Okay, this is a one proportion z test. So we're going to choose number 5, the function here, one proportion z test. And this function requires values for the following entries. P sub 0. P sub 0 is the percentage or proportion in the claim. Okay, in the claim is 25%. And X is the number of successes, 135. N here is the sample size. Remember, the number of green peas plus the number of yellow peas, right? And then we're gonna select two-tailed test. If your test is left tail, you choose the one in the middle. If your test is right-tailed, choose the one on the right. Since our test is a two-tailed test, you have to select the first one. Okay? Yeah, this basically gives you the alternative. This here actually is the alternative hypothesis. Alternative hypothesis determine the type of the test. We have a two-tailed test, so we need to make sure this is highlighted. And those color, it really doesn't matter. You can customize that and then calculate, and you will have those result. And Z here is the Z here is the test statistic. Z here is the test statistic. Capital P here, that's the p-value. The problem requires to use the p-value method to make a decision regarding the no, right? Since our p-value is 0.3099, like almost 0.4, almost 0.4. Let's look at our significance value. Our p-value is pretty high. P-value is 0.399, okay? Is higher than the significance level. Yeah, a lot of higher, like multiple times higher. So p-value is high, no must fly. P-value is high, no must fly means we fail to reject no because the p-value is high, right? Higher than the significance significance level determined by the researcher. And since we fail to reject no, and in this case, the original claim is the same with the no. So if we fail to reject a no, then we fail to reject the original claim. So the conclusion would be we fail to reject the original claim. Means we do not have sufficient evidence to warrant the rejection of the claim that the offspring P's will be yellow. The percentage is equal to 25%. All right. Yeah. Read carefully the 4 answer choices. The difference is kind of like subtle, but use the logic. Use the logic. I hope this helps.